So people that are not native to AI and not native to IT also have accepted that AI is relevant. I mean, there was a study last year that said that more than 80% of all the executives know they won't be able to achieve their growth targets without AI. And some even believe they will be out of business without AI. And then we have the third dimension of actually AI becoming part of our user interface. It's like, think of chatbots, think of virtual assistants and stuff like that. So AI is everywhere, but still we struggle because it's a very, very long way, and we all probably know that and experience that over time. It's a super, super long way from a model to actually bring something into production. I mean, the Gartner numbers from 2020 here are, I mean, not surprising. And a little bit older numbers here saying that only 3 out of 20 projects actually survive. This is quite dramatic. I think nowadays we're a little bit better than 3 out of 20, but still the way from a model or prototype to production is a very, very long way. Why is that though? A few key things that we are lacking is integration, maintainability, and we very often struggle with organization. Integration in terms of, I mean, if a data science project, if it runs on an isolated notebook, it often has no connection whatsoever to the real world. Like, we're working on exported data, on data that we cleaned by hand with very little automation in between, or sometimes even not automatable at all. We're not integrated. We're not working in a classical IT environment. We're working in a notebook or in a prototype environment. So, and this often is also something that's only understood by scientists. If you ask someone who is administrating the servers, or I don't know, a Kubernetes cluster, this person might have no understanding of what you're actually doing with data and what you're actually doing in your notebook. The other piece that we often lack, if we think of our prototype environments, is maintainability. And I have a nice example about that later. But the whole topic of, well, we develop a model and then, well, we think we're done. I mean, we all know, I mean, there needs to be retraining and stuff like that, and we think about that, but in the end, it's also organizational question in terms of who maintains that. If even with a simple thing, if I bring a chatbot live, who actually owns it in the end? Will there be a data scientist team that is retraining the bot as soon as new products are there, or as soon as new content is there? Who actually cares for the content? Who owns it? Who watches it? So not just the business monitoring and not just the IT monitoring, but the actual business ownership. And can IT actually run our little AI solution? Do they understand it? So maintainability is usually a huge deal breaker when we think of running AI in production. And then lastly, it's not just the IT, it's the organizational matter. Very often we fail because of the organization, because of the people in the organization. And I have a few examples of where we failed really badly. So, but first of all, why is that so? I mean, this is a rather old picture in 2014, but it's nowadays more true than ever. That was from a paper that was actually comparing from a real world production system, how much of the code actually is ML, and it's 5% or less. That's something, of course, I mean, it makes sense if we think about it, but do we think about this fact while we're setting up a prototype, while we're trying something new, while we think, how do we test this now? So it's all these elements that we tend to ignore. And this is just looking at the code of an application. This is forgetting a few other things. Why do we struggle so much to get this full picture into the view? This picture here is all these boxes around the ML code. This is IT. traditional IT elements. And data science is not IT. Data scientists and AI experts, we are rarely programmers. We are rarely IT architects or DevOps people. On the other hand, we cannot really rely on traditional IT people to support us because we're doing something new from an IT perspective. Always think of it, AI is new if we think in IT terms. I mean, look at companies that are running mainframe code that has been developed 3 decades ago. AI is a very new concept and requires new understanding of IT. So yes, data scientists, we're not IT administrators, we're not programmers, we're not architects. And there are IT people for that, but we need to bridge an understanding. And we need to have our own understanding of IT, but very often we don't. To give you one little example, let me tell you the story of a UK government agency. This is probably 2 years ago, 2 or 3 years ago. They have set up a garage. So 10-something data scientists, bright young people, good mix. They were asked to build a chatbot for the employees. And well, we're agile, so we're looking at, let's start with something small. Let's do a pilot, let's do a prototype. Let's start with security topics, stuff like resetting my password and these usual things. So the team got on to work, and 3 months and more than 100 interns later, we don't have a bot, we have chaos. Because what they did was they took Python, Spacey, and started to, well, collect the data, talk to people, train something, train classifiers and stuff like that. They didn't use tooling in terms of, well, what's the overall development cycle? How do I look at a great picture? They also didn't look at, are there commercial or even are there any open source conversational AI frameworks? No, they stick to, well, this is a text classification problem, but we have our libraries at hand. Let's use Keras, Spacey, and play with it. Also, they didn't understand the domain really. They were asking for people to get lots of examples, and they weren't able to really understand, well, how many samples do I need to train it properly? So in the end, the performance of the classifier that was basically the chatbot was not so great. You need actually, if you use it, you need to first press a button. To which topic am I asking this question now? Because the whole classification system wasn't able to cope with all the different intents and disseminate them. Also, they didn't even think of conversational flow design. So it was really a pretty much broken system when I want to change my password. Also, backend integration was not possible. Extension to the next topic was not possible because, well, the classifier broke. So in the end, it was a failure. Why does these failures happen? Well, there are a few paradigms that we see again and again and again and again. We are all, well, we're techies. We love that stuff. This is why we do it. And this is why we want to try it out. So we stick to what we know. We learned Python. We learned how to use data science. We learned how to use TensorFlow, Keras. We see papers. We see stuff on GitHub. We want to try it out. And not only do we want to try it out, we also don't trust what others already tried out and failed on. We want to try it out ourselves. We want to train the model ourselves because we think, well, we can do that better probably, or we want to try it. And then also, I mean, this is inherent with any project. And I mean, I'm from Accenture, we do projects for a living and I see it every day. There is this tendency to pick and choose whatever cool library is there and build it ourselves. I'm doing that myself. People don't have interest in, well, there's a commercial option that is readily available. Let's just use that, because then I'm not building it myself. And then often through that, teams, they actually lack knowledge about what frameworks are there that do a lot of the work already. So it's curiosity on one side, but also it's a lack of know-how. And a lack of know-how, not just in terms of, well, what are commercial options or what are frameworks or how do we actually do this whole boilerplate piece, but also in terms of cloud. And this is something, this is sort of, I'm always doing that as a wake-up call because I see it everywhere. We all now know cloud. There is no single person in this call that doesn't know cloud or has even played around with cloud. But I mean, there are multiple aspects of cloud. And the thing I'm talking about is cloud has revolutionized IT. And what it did is it changed the speed to production through abstraction. But if we look at the data science usage of cloud, we often see stuff like, hey, cool, now I can run my notebooks in the cloud. Or stuff like, hey, this is a place where I can get compute resources. But what cloud really is in lots of IT and business perspective is the fact that, hey, we can go way up higher in the abstraction levels. We can talk about software as a service. If you think of AI, this is the difference between, well, running my notebook on the cloud and using AI as a service like, I don't know, Google's AutoML or something like that. These are things we often don't look into because, well, they're black boxes. This is not of interest for us as data scientists. But from a corporate perspective, this is something else. This little UK or this big UK agency, after the 3 months failure, what they did is they spent 2 weeks running a bit through the data and loading it into one of the commercial cloud services for chatbots. They had a way better results than after all the struggles before. But I mean, what I want to bridge here is not, well, there's everything commercial with the cloud, use it, but it's rather look at the patterns. This is what we often fail. These huge hyperscaler provided us a huge amount of guidelines on how things could be done. So it's always worth, and that's for every data science project I'm starting, it's always worth to say, okay, let's look at how the cloud providers are doing things. Because they are spending millions of dollars and brain power into building these patterns. And this is why the project in the UK failed. They didn't thought of how are enterprises doing things, instead of playing around. And this is where a lot of these AI projects fail. So when AI is everywhere, this actually means a huge part of our AI projects and the success for us is integration. We need to learn how we integrate beyond notebooks. Stuff like, where is my data coming from? When is my data actually coming from? Are there batches? Is there a database? How is my model being created? What are my deployment artifacts? What I'm actually generating is, I mean, I can't bring a notebook to production. So what is my deployment artifact? Am I building microservices? Am I building jobs that need to run somewhere? How do I monitor the whole thing? And if my AI application should go into production, then there are all these little illities, as the IT architects call them, stuff like availability and reliability. How do I make a model deployment in a way that it is available 24/7? Do I deal with backup, with active passive? Usability, is it actually callable? Is my bot usable? Does it work with end users? Can it scale? If I'm building a price optimization service, can it scale to actually the levels that the shop website is using? Is it maintainable? Can I give it IT and IT can actually run it? Or do I need to come back to me as a data science team to make it work? So a lot of integration topics that we need to think about. To give you one example, this picture is of a bot deployment in a project. So you see, again, like in this little Google picture, the AI, and even in that case, it's Rasa, the AI is the little piece in here. All the rest is integration, is boilerplate, is what make this project actually happen. And there is stuff we as data scientists also need to think about. I mean, look at the different zones. In that case, with that client, data wasn't able to pass directly from system to system. Stuff like indirect communication. This has performance impacts. I need to tear apart Rasa services and framework components to make that happen. And this is not IT doing. I need to think of that. Also here, that client said, well, expose a Python web service to the website. No. Whatever we expose, this cannot be Python. Also, it cannot be WebSockets. So it's integrational elements we need to think about. Can you write a middleware in Java Spring Boot? Maybe not. So we need someone that can do that, actually. And then, I mean, often a topic, and you see it here with different data zones, security. I'm not allowed to store like end user utterances in the session database, but this is needed for the chat flow to work. So you need to change, you need to play around with it. And then lastly, of course, also in terms of deployment, you probably have deployed something in Docker, but with that client, well, we couldn't even deploy anything because they said, well, you cannot use the Docker images that are out there. You need to create everything based on a SUSE enterprise Linux because we need to have supported Linux. We're in an enterprise environment. So you rewrite all the Docker containers and stuff like that. In the end, it took over a year to make that all happen. And obviously, building the bot, doing the NLP, training BERT models and stuff like that was only part of it. The rest was really making the whole integration happen. And it's not IT that will deal with that. We need to work together. Data science is a team that needs to be actively involved in. And it's not just the deployment, it's also the way we develop. I mean, DevOps is something we all know, but how deep do we follow that process? We know professional programmer would develop and deploy without DevOps nowadays. But as data scientists, we're often not developers or DevOps specialists. So we need to learn how to fit, for example, in a corporate DevOps environment. And also we need to think about model ops topics if we want to run in an enterprise context. Think of stuff like model maintenance, model versioning, reproducibility. Am I storing my hyperparameters? Where and how? Can someone actually trace back which model worked why? Also from operational perspective, think of this little bot project I just talked about. In the end, we had multiple bots. So how do we actually do training? How do we do training parallelization? We don't want to do manual training jobs. This whole thing is an integrated DevOps topic. And then also, and this is again something very critical, the data. It's not just exported data, but how do we integrate the data flows into that? And as data scientists, we need to know how we play in that field. The very best advice, again, look at the hyperscalers. I mean, Google's Vertex, Microsoft Azure ML, Amazon SageMaker. These are ecosystems that evolved around the idea, how do I do this in an enterprise context? Or even the open source products, like look at Kubeflow. It evolved out of this idea of how do I do training in a enterprise way, in an ML, how do I enable MLOps? So coming back to my little example of the bot project, there is another aspect that needs to be added to it. Well, and this complexifies the real world even more. Of course, there are multiple environments. There is a dev environment, the training environment, production environment, and then little stuff like, I'm not allowed to see feedback data in development because it's production data. So corporate security says, no, you can't use that. So you have to deal with those issues that take way more time than the actual training of the models. And then again, we're facing with AI still challenges that are not there for the classical IT. This little box here, Nexus IQ, well, that's a scanning software, Sonar type software that is actually scanning for vulnerabilities to make sure nothing gets into production that has known vulnerabilities. But Nexus IQ has no clue of a Python ML model, and even sometimes has no clue of Python libraries at all. So the IT, the traditional IT, they weren't able to let our models into production because they weren't able to scan it for vulnerabilities. Which means we need to talk with them, we need to teach them, we need to work with them. This makes project durations way longer than originally anticipated. But it's not about being infrastructure. It's, of course, also data. And I mean, I'm not going to tell you about the problems we have with data. we know that this is classical data science work. We know we have to be careful with what we interpret into data, and we know data is never ever in the quality as we want it. But there's more to it, of course. If we think of an enterprise setting for an AI application, we need to think about stuff like training, governance. Imagine the following: a project a couple of years ago. A client wanted to have an AI that is looking at tickets, support tickets, and automate the answers and also trigger the right backend process. Like, I don't know, I need to change my password, do that, something like that. And we had a lot of data, 8 or 10 years going back. Of course, you probably got the idea. 10 years worth of data for an IT support, this doesn't work. So you can throw away the older 6 years and only look at the probably last year or something like that. But the problem they had was also, while they had data, they only had the communication. They had the tickets, the questions and the answers. They hadn't saved the state of the user, the state of the system, what processes were ever executed and stuff like that. So in the end, we were throwing everything away, starting capture of new data in a way we needed for training, and first did 6 months of capturing of data. So data and trainability of data is also something in lots of enterprises, it simply doesn't work. Also the governance topic. Another client project, we were looking at document analysis, like forms that, in that case, insurance customers had filled out, and we were processing these forms. But I mean, traditional client, so you have, of course, data protection topics. And in that case, the client said, well, you're in a development environment when you're building your models. You cannot see customer data. You can only see anonymized data. But we cannot train all our models because some of the models are relying on actually extracting and acting upon these personal data. So you end up with questions like, how do I actually anonymize these data when I can't look at it? How do I make sure I get the right data? How do I test it? If I can't do the tests on data, if I can't see the data, where do I test it? You build stuff like there's a development environment where you work on anonymized data, you build integration environments where you can test on real data, you try to interpret feedbacks and stuff like that. And you actually think about how can I do anonymization that it works. But also governance is about topics like who owns the data. Very so often we see, well, we want to start the project. Yes, of course we have the data, but we're not sure if we can use it, if we may use it, if it's complete, all that topics. And the more we get further with our AI projects, the more complex data gets, the higher our data requirements and our training environments are, the more fragile we are, and the more sensitive we are to the topic of not having the right access to data or only having conditional access to specific pieces. And then, of course, the last point, I mean, data is living. Also, we all know that models can degrade over time and stuff like that. So we have our means of monitoring models, but it's also about thinking of the business process. I don't know, think of a chatbot that is talking about products or price optimization or whatever. How do I know that we have a new product? How do I know we're releasing new features? How do I know we're changing the process? So the more AI is becoming a centerpiece and is being embedded in processes, or is the UI with a virtual agent, the more we are dependent on the business processes in the corporations, which means we need to know when something changes. And then, well, who maintains that? Who retrains the model? If you're external, are you coming back to the client and changing it again? Does the business do that? Does IT do that? Who does that? And I mean, while we are at retraining, that brings me also to the topic of testing. Testing is like documentation. I mean, no one likes it, and we tend to do it more or less. On the other hand, a company like Accenture, we have more than 30,000 people just in the testing practice. Why is that so? Because, I mean, IT projects fail and everything we do in IT fails. We know that. And with AI, it's not just about testing an IT system, but it's also about testing what we do content-wise. Think of a couple of years ago, IKEA had a bot on their website. And well, you could ask the bot, show me chairs. And well, the bot would use the website to show you all the chairs that IKEA has. Then you say, well, show me red ones. And then the bot showed you all red products that IKEA had. Plain, stupid, simple. The bot didn't know context between different questions. This is something we see every day, and probably all of you stumbled upon bad chatbots. It's so easy to build a bad chatbot. It's a topic where involving end users is not done. And this is so important. People, we assume, well, we know what our client wants, we know how people speak. We don't need to test with end users, but testing, especially testing with those people that are involved in it, is extremely important. Or even worse, think about introduction of bias or underestimating feedback loops. It's probably one of the easiest way to actually end up in newspapers. Think of Microsoft building the bot that went Nazi, or a lot of algorithms that favor white males. These things usually only turn out after testing. And if we don't do it, this is something, the worst thing we can actually do. And sometimes it can be very hard to do that. It can be very hard to teach an organization. For example, we need to involve end users, or we need to do a completely different type of testing than classical IT testing, which brings us to the organizations. Organization and people are, besides the classical IT elements, very often reasons why AI projects fail. Organizational struggles. Let's look at 6 typical things we see over and over which make AI projects fail. First thing, let's waterfall an AI project. I mean, probably we all know AI is something that we want to do agile. Before we start training, we have no idea if that works. Before we have looked at the data, we have no idea what the outcome will be. But still, we have lots of situations where this is bluntly ignored. I remember a bank, they were doing agile and stuff like that, at least on paper. We were doing workshops for an AI project. They understood we were doing some of the first ideas of a prototype, and well, it looks good. So let's kick off the project. Let's just finalize the commercials first. Yeah, management needs to have this all as a fixed price, and we need to put into the contract that the project is successful if we hit 95% accuracy. That's stupid. You can walk away from a project like that, because management or project controlling isn't able to cope with an agile project here. And I mean, 95% accuracy, that's easy to fake on any model to reach above 95% accuracy. But what does it tell you in a business perspective? It could still be completely wrong. I can train with trained data and test with trained data. I'm very easily achieving high rates of accuracy. So the organizational mode, how does an organization do projects, is very important and has a high influence on how are we successful. Being able to run agile is, for me, a prerequisite nowadays. I don't do non-agile AI projects. And I've seen it with so many clients. Yes, we are agile, but no, they aren't. So this is also something, be agile, and from a data science perspective, push that into a project. in order to have it working. The second piece, the traditionally strong relationship. Well, we all know it. In most enterprises, IT and business don't really talk very well. They don't go along very well. And I still remember a large manufacturing client. They wanted to do conversational AI and actually, in the end, get rid of the call center and stuff like that. So actually, IT got budget and built a conversational AI platform. In the end, it wasn't used because they couldn't implement any use cases. And they couldn't interpret the cases, they couldn't interpret the process, they didn't even have the data, understood the data, because business at that time was not interested to help them. So another 1.5 million euros just blown into the wind because IT and business didn't work together. Same for this fire and forget idea. I mean, it's the same like backups are for cowards. And this is the same for AI. The AI analogy would be, well, I don't need to monitor my models. I don't need to monitor my AI. And in fact, there's a study from last year, 2020, where it says that 67% of the asked organizations, they don't monitor their models. They just wait for it to break over time, maybe. This is not just technical monitoring. I mean, IT usually monitors. I mean, if my Docker container falls down, IT will bring it up. I can trust that. But business monitoring, model integration, I said, new products, change of text, change of models, stuff like that. You need to plan that in. And in terms of planning, also in terms of governance and responsibility. Governance is something, when it comes to AI, most companies still lack. If you look at large enterprises, you usually find something like, I don't know, an IT white book or IT green book or something like that, where it says, well, this is how we do problem X. If you want to have a database, you can have Oracle or SQL Server. These are the two databases we have. But if you ask them, so, well, what AI frameworks are you using? Or even more simple, I don't know, what technologies you're using or whatever, then usually there is no standard because it's a new thing. There is a large telco company that was playing around with bots all over the organization. And they were building 20-ish different bots on 17 different frameworks and technologies. So you can guess how many of these 20 bots actually made it to production? None. Because they saw, hey, from an IT perspective, before it went live, they said, no. You're all starting the same bots, basically. I mean, bot is a bot. 17 different technologies, that doesn't work. We need to do an RFP. We need to see which vendor we want to play with. So they started serving 26 different vendors and technology providers for bot technology. And guess what? They're still surveying it. So it's hard to see this whole governance aspect. It's hard to bring it to a point where it's a balance between trying out things and agreeing on standards where we want to go in production. And this is not just on technology, it's also on data. Like who owns the data, who ensures it stays current, and stuff like that. And also from a project perspective, responsibility means there is a sponsor. It's one of the first things I look at when an AI project comes around the corner. Like, who is actually sponsoring it? Who has the budget? If IT is the sponsor for a business-driven AI project, could be dangerous, could be it doesn't actually work, or there's actually no real sponsor. Same with the life cycle. It's also about sponsor and budget management. We touched upon that before, like building a bot or building a new customer service interface. Who is managing, who's retraining the bot, who's managing the content? And if we think of AI as UI, well, and we see that those projects more and more, like replacing ticketing system with AI, with NLP, or building bots or something like that, that serve as the new customer service UI, who is handling the fallout? Who is handling the conversations that drop out? We probably now need to hire chat agents that do human chat. Oh, we don't have that before. So we're changing actually the organizational structure. Also brings me to the point of skill. Do we have the right people? And this is something that, if you look at it honestly, it's very hard. I mean, I'm doing solutioning of AI projects every day, so I have an idea. What roles do I need in a team to actually make an AI project successful? But this is something, this is very expensive. And this cannot be compared to, let's do a prototype. For a prototype, I don't need an architect. Probably don't even need someone from DevOps, so on. But still, if we look at most AI projects, we need someone from the business. We need someone to understand the data. We need a business analyst or someone. We probably need the designer. If you build a bot as a data science activity, it's easy if you use the frameworks, but you need someone to design all that stuff. I'm staffing marketing people, content writers into bot projects, to make them good. And also on the cloud side, like, do we know someone that has DevOps? Do we know MLOps? If we want to do an enterprise bot project and don't know anyone who has any experience with DevOps and MLOps at scale, then how should that work? And then, of course, if we add all that up, the budget topic, I mean, time, budget, features, that breaks anyways half of all IT projects. We're always over budget over time, or with too little features. So of course, this is just another dimension on top of the AI problems. But it's not just the organizational pieces. There's also the people angle. And AI has an effect on people. Let me give you one example. There was an insurance company. They had the idea, let's automate the inbox. So we're scanning documents, like I'm writing my letter, they scan that, and right now humans are looking at the document, saying, okay, well, this is account termination, this is insurance claim, and well, classify it, sort it, whatever. We all know here in the group, well, that's a super, super easy thing for an AI to do. Let's train a classifier. And well, with that insurance, it worked super good. It worked very, very good, obviously. So we did a pilot, planned it out, good results, very good results. Now let's look at production rollout. If we roll out the system into production, then we have to let people go. And we have to terminate quite some people because we don't need them anymore. This is something we cannot do. Let's better stop the project. So, of course, I mean, the AI was successful, but the people effect was completely forgiven. It can also be the other way around. There was a project where we wanted to build an AI that is taking off calls of the call center. Like, what are the top 10 problems people are calling? Let's build a bot that is handling at least these top 10 calls and then solving the problems. So the client didn't really have any good data, no data at all, no usable data at all. So we said, well, that's easy. We have, we have over 100 call center agents. They can help us train the system. So when we started the project, it took about a month to realize we will never get their help, because we were at first had some little talks with them, but then, well, they didn't show up to the meeting. No one has time. No, you can't really go into the call center and look what we're doing. No, that doesn't work. The security, that doesn't work. In the end, it turned out, well, these call center agents, they were fully aware of what we want to do. And they were afraid, because if we introduce this bot, they will lose some of their work. They will lose people. So why should I be so idiotic to train the system that replaces me? I mean, there was a communication problem. What we nowadays do is we tell them early on that we change the tickets that come. They can spend more time on the complex tickets and get less of these redundant tickets where they anyways just click it through. So it's something we need to make really sure. We need to work with the people that are affected by the system. They need to help us teach the system in the right way. So they need to be involved, and it works. If you go and talk with people, if you work very early on with them, then these things can work. But if you ignore them, the effect can be devastating. And talking to people is also about the second angle here. I know what my users want. This is something I've heard so many times when doing bots or ticket automation or something like that. Voice of the customer, we don't need to ask the customer. No, I cannot do bot training with my customers. That's insane. And so you end up with bots like the IKEA bot that was never tested with real end users before being released. And sometimes you even see, like, again, we are in these organizational borders. Who talking to the call center agents that actually handle the calls? No, that's a completely different organization. We can't do that. But I know exactly what the type of tickets we are. We have all that documented. So I know what my users want. I know how my users speak. This is a trap. Lots of corporations, and it can cost you everything. In the end, you release really bad systems. And this also has something to do with management and understanding AI. Another little example is another insurance. They wanted to say, hey, claim submission, like my car is damaged, I need to file an insurance claim. Let's do a chatbot for that. Great idea. So we did a nice chatbot for that, like design thinking, writing good stories, thinking of, well, how does a user actually want to submit that? What questions do I ask? Multimedia, like I can use a map and stuff like that. So a good thing to be deployed on the website. And then management said, it's an interesting thing. That's cool, but let's test it first. I don't want to expose something like an AI to my customers without knowing that it will work. So let's first deploy it only to the internal people. So like the people in the insurance agencies that file a claim for a client, for a customer. And of course, it failed because, I mean, if I'm an insurance agent, I know how to file a claim. I don't need a chatbot to guide me through. This chatbot was intended for end users, not for insurance agency employees. So a very good bot in the end failed completely. And also, I mean, think back of this example with the project. You need to have 95% accuracy to have a green flag on the project. This is because people don't understand AI, and these people are in the management. I mean, this is not just management. Hybrids. We think we can handle it. This is something also so many people, I mean, this is in general about all projects, not just AI. Our data is good. Our IT can handle that. Yeah, we have all the data you need. Cloud, yeah, we use the cloud. No problem. That stuff you see all the time. But the reality is sometimes a little bit different. Like, I still remember a client IT telling me, well, because we said, well, we need a real server, we need something to have with enough power to train models. And I got to hear, well, your server is like a child. It takes 9 months from order to delivery. So let's plan that into your agile project of 6 months. No. Or other example, also a client where we were building a customer interaction, so some virtual agent integration, as we said, well, we need cloud because, I mean, speech to text, all that stuff is on the cloud. We don't want to go down the road of building something on-prem there. And they said, well, no problem, we have cloud, like we have Azure and AWS, no worries. And then it turned out, yes, they have Azure and AWS, but they don't have a link between the cloud and their backend systems. So you could build something, you could run it in the cloud, but these systems can never, ever ask the CRM system or can never ever trigger anything in the backend because there is no direction from the cloud to the own data center. So it's a lot of these things, then also integration into the actual, let's say, big application. I don't know, we're building again, price optimization engine. Let's integrate it into our shop hub. You can build your models, but well, we release quarterly, so you cannot really test the integration. Or yes, of course, we are agile. We're running a release train. Just put your integration release onto the backlog of a release train, and probably in the next 2 or 3 years, you'll get integrated. So reality and what we think we can do in IT are two very different things. These are things we need to play around with. And then, I mean, responsibility, mentioned that earlier. I mean, think of Google's little image tool that was classifying people of color as apes. This didn't end well. The Microsoft Nazi bot didn't end well. But also think of Austrian labor agency. They were building a matching algorithm that were matching people to jobs. And it turns out, well, it favors men over women because of bias in data. Of course, from a data science perspective, sometimes it's easy, sometimes we even know, I mean, well, the data is biased. Well, obviously, yeah, well, we know it, okay. But the people trying it out in the end and putting it into Bild-Zeitung, they don't know. So you end up with the worst publicity you could ever think of. Really take a look into that. Be really aware of bias. From my experience, if you screw this thing up, this is where it hurts most. You are in the newspapers, and this is really, really bad. And then the last thing that also is something we as people tend to do, and this is not just management, it's also we as curious people, fascinated by technology. It's this AI for the sake of AI topic. We want to try it out, it's cool, hey. Well, we should apply a transformer here. Let's not use one of the existing things. But also stuff from management, like, if we're buying a new product here, it has to be AI. Because, well, I read in the Manager magazine that AI is something we need to do. So very, very often, I mean, it sounds ridiculous, but very, very often we still see that. People applying the wrong technology, salespeople from tech corporations selling the wrong technology, we wanting to focus down the wrong path, IT coming up with, well, we have a, I don't know, Cloudera cluster. This is for AI. You need to do it there. So this is something we need to be aware of. And this is something that can completely destroy a project as well. So if we go back to this original little picture from a couple of years ago, we can add a huge amount of topics to the original picture. And this, of course, again, the AI piece stays this little dot in the middle. Of course, I mean, you don't need to solve all these things by yourself, but you need to be aware of them. And again, the reason why you, as the AI guy or girl or the data scientist, need to be aware of that is we are living a different pace. I mean, AI has evolved from something done by scientists to something that we are exposed to every day in our daily lives in less than 10 years. Now, if you go into a large enterprise, how old do you think software and pattern and infrastructure is? Well, of course, they're new servers, but I mean, there are clients that are running the 30-year-old mainframe core banking application because it runs. Now, think of DB2 and Oracle are our only database systems. The rest is not in use. For IT, I mean, SOA is sometimes the latest hype for IT. It's simply IT and business cannot cope with the speed with which we in AI not just develop our algorithms, but also the way how we need to integrate it. And I mean, of course, there are people, the Googles, the Amazons, the Microsofts, and the other providers, they are in this space. but most companies are not at that point in time. And the only people that really understand AI, well, are we AI people. So we need to teach the organizations. We need to educate IT. We need to educate our stakeholders and management. And sometimes do this really brutally and honestly in order to make it work. So, a little summary. A few things to think about when looking at an AI project that you want to sometime bring into production and not just have a little experiment. Pick the right problem. Always ask why and how you want to do something. And don't be afraid to walk away. It's stuff like, look at who is the stakeholder, who are the stakeholders, who is the sponsor, for whom am I building this? What business problem am I actually solving? Are we doing this for the sake of technology? Are we doing this to solve a problem? Are the people involved in that problem actually? Do we have the data for that problem? Are the expectations right? Is there probably a lack of understanding of AI, of ML, or is this actually something realistic? I would say about a quarter of all the problems of all the AI projects that are on my desk are outright not working. Because, well, it simply doesn't work. It's science fiction, or the client is not ready to do it. It's mostly the client not ready. Then talk to all people involved. I mean, this is something, and we as IT geeks sometimes have problems with that, but AI, and especially NLP, is a people business. We are automating people's lives. We are creating systems that humans need to interact with. They need to teach us how to train it, and we need to implement processes that we can explain to them. So you need to explain to them what you want to do. You need to take the people with you. You need to involve them. Otherwise, you'll fail in most of the instances. Or you build something that is not understandable by the people involved, that is not understandable by the stakeholders. You know, wrong expectations, wrong outcomes. You can still have a model with 99% accuracy, but in the end, it's wrong. So talk to people, communicate. Then also, and this is especially if you want to go to production, think of the life cycle, think of the entire life cycle, and do it early on. Think of these illities. Google the architectural illities. Think of this list of sustainability, availability, vulnerability, all these things. Think of those, even before you think of what model do I build? Because in the end, if you want to build something that lasts, you need to think about how can I do that? And this changes things. If you know, like, I don't know, I'm building an engine that needs to be called with every single click on the website, well, then probably we choose a little bit different technology for that. Or we even train different models. We use different data. We expect different things. And this is also where we need to learn. We as data scientists, we as AI community, and learn. And then I'm looking into hyperscalers. They are putting so much amount of money and brain power, especially into how to abstract things, how to industrialize things, how to at the same time stay secure, scalable, manageable. Learn from that. Use the patterns the cloud has. Learn from that. And if you want to learn, well, be humble. This whole thing is a team play, except that as AI, we are a piece in a puzzle. Remember, even the original picture at Google, AI was 5% of the overall code, 5% of the overall picture. So be humble, play in the team, except that none of us, we don't have all the skills. We need to work together and play together. Thank you. Questions?
Yes, thank you very much, Sebastian. I really appreciate hearing this. I think we will extend a little bit the session because the plan was to finish in 1 or 2 minutes already, but we will extend until 10 to 3, and then we will have a chance to discuss with you also in the Gather Town, where you will have some location where you are located, and people can come to you and discuss. I want to start the discussion briefly with a remark or a question. So when I started software engineering in the 1990s, the goal was, or the rule of thumb was, if you have a project estimation, you should at least duplicate it to get a real estimation. Now, when I started NLP and I started to gain experience and I give talks now, I talk to people, I have one slide at the end which says, well, do a lot of things if you start an NLP project. One of them is triple the estimate. Now, if I see your slide with the AI component in the middle and then all this stuff around, I think the factor is something more than 3. So could you make a good estimate of how much more it should be? So given an AI expert tells you, well, this is a project of $20,000.
My rule of thumb here, like doing a prototype, doing something on a notebook, I don't know, 6 weeks, 8 weeks, something like that. Doing in production, just turn the weeks into months and then multiply it by usually by 1.5. So I don't know, if you have 4 to 8 weeks for a prototype, take a year to bring it in production.
Okay. Okay, thank you. Okay, there was one question in the chat, probably in the same direction by Egon Verlen. Am I right? The best way to use AI is starting with a small project, integrating all that it needs to succeed, and then to scale it up.
Yeah. I would always say that there are multiple things that need to run in parallel. So yes, a speedboat, a prototype is the best thing, and going stage-wise is always the best thing. I mean, this is the whole idea of agile, step by step. So yes, always do a prototype, and sometimes even clients don't understand. I've seen clients that didn't understand, but that said, no, I have the money, I have the budget here. I want to do the real project, not a prototype now. Well, even then, let's start with a prototype. But the other thing I'm also looking at nowadays is, yes, do a prototype, but think about, in the same time, think about how will we later be able to do in production. And this is especially in terms of like, if we do the prototype and we can run it on our notebooks, on our laptops or something like that, but does this client, does this enterprise actually has the capability to support me with DevOps, with MLOps? Or I don't know, if I'm building a project to do this example from earlier, if I build a project to do a bot that should take over customer communications, have I thought about the fact that if I roll out this bot, I need people that handle the fallout? So all the dropped conversations, because otherwise my customers will have a horrible experience. So I think it's always both ways. It's on one way, you proceed with a prototype and you do a prototype and do a speedboat or however you want to call it. On the other hand, talk and work with the organization to make right early on, make sure that this prototype actually has a chance of surviving afterwards.
Okay, thank you. Other questions from the audience? Yeah, sure.
Thank you for a very nice presentation. I need to ask a question actually related to the issue that you mentioned. Which kind of a skill a data scientist should have, like as a software developer? I mean, in which level, for example? This is my first question. The second question is that if someone like know how to prototype using, as you mentioned, Jupyter Notebook, know how to code in Python, how much does it take to transfer to get such a skill like a professional software developer to write a clean code, and how much it is important? This I mean, I guess it's very important based on your presentation.
Yeah. So I mean, both questions are sort of interlinked. I would say, I mean, the short and easy answer is don't even try. So I've never met a person that brings all the skills from the data science and prototyping models, whatever you do in Python in a notebook, down to how do we deploy it, how do we test it, how do we integrate it, how do we do the UI. This is so much. This is branching over all aspects of IT plus the business. So no one will ever probably really do that very well. So in the end, this is a team effort always. And I would say, if I look at the roles and the skills, well, besides the data science skill, the core things I'm always looking at is someone to test, someone who has responsibility to test, someone with integration skills, at least. So a developer, integration developer, very IT-affine guy. At least some portion of architectural know-how. And even if the client is very good at providing a lot of that, you need to bring that to some extent. And the last thing is business know-how. So what does this data actually mean? How do I use it? How do I work with it? Then DevOps skills. If you want to do it in production and not just once, you need to build up a DevOps chain, you need to build up MLOps chain. So you need someone to take care of that, this whole chain from development to production. And lastly, probably if you're building something like bots, you really need to think about, I don't know, someone who designs it. So in the end, I mean, also we as the Accenture, as a consulting company, I don't bring all the people always. It's a mixture. Like if I'm going with, I don't know, a developer and a bot designer or someone like that to a customer, I expect from the customer to have the other people. And this is again a trick. I mean, but this is a pitfall with every IT project. If you work with clients, or even if you work with other organizations inside your same enterprise, well, yes, of course. I mean, the business will say we support you. Yeah, no, of course. I mean, we will be in every steering meeting. And this is not this kind of support I'm talking about. I need someone to actually tell me, work me through the data, be here at least 4 hours every day. So something that is distributed.
So maybe this is the very last question. If you want to suggest a source for someone who is good in programming and Jupyter Notebook, and he wants to I mean, I know that it's a different role, but if you want to suggest a specific source for this, to get my Jupyter Notebook, which is with a flare, a spacey, all of these things, wants to convert it to the reproducible code somehow. What would you suggest? I mean, which source would you suggest?
Actually, a very easy thing. Go to the hyperscalers, do the cloud trainings, and do 2 types of trainings. One is the actual basic training, like it doesn't matter, AWS or Google, they're all more or less the same. The understanding of how cloud works, how DevOps on the cloud works. There are beautiful trainings out there because, I mean, these providers want to push their stuff very hard. They're very good. They teach developers, scientists, even business people how DevOps work, how productization works, how scalability works. So these are very, very good. They also have pattern libraries that tell us how to do architecture on cloud native, because they want to sell their cloud native services. But these are good things to learn. These are really good things. And the other piece is, if we look at the large hyperscalers, they all are building up right now, some are faster than others, these enterprise AI offerings, like AWS SageMaker. It's not just a service with notebooks, but it's an ecosystem of services that do model op and DevOps and integration and data cleansing and blah, 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 blah. Or same like Google Vortex. Even things of stuff like explainability and so on. So looking into those services, looking into the tutorials, playing with those services, gives a huge understanding of how a productization of AI can look like. They're really good and free learning things.
Many thanks. Thank you very much. I enjoy your presentation. It was very, very interesting.
Thank you.
So Thank you again. I think we need to have a short break before we start the next session, so we have to interrupt here. So the next session starts at 3 on Zoom, as I said, and Sebastian will be afterwards in the Gather Town session. There will be some location. You